Alright, this is OEH 5723, homework 2, problem I. And in this problem, we are told that we need to be able to detect methyl isocyanate in air at 0.02 ppm. And we have a lab selected, and the lab has a limit of quantification of 0.07 micrograms. So this is a pretty typical situation where you have a lab that has a limit of quantification. You have an agent that you want to measure, and you're not sure how much sample you need to collect, so that when you send that sample to the lab, you'll get a real number back. Because if you send them a sample that doesn't have enough mass on it, they'll send you a result that says less than reportable limit or less than LOQ. So in this case, they'd say less than 0.07 micrograms. Well, is it 0.69 or is it nothing? You don't know. So this is a pretty important real-world situation, and this is going to require a little bit more logic. So let's start off with our chemical. I'd suggest you use NIOSH Pocket Guide to look up most of these chemicals and get your basic information. So methyl isocyanate is CH3NCO. There's a double bond between each of these, and the molecular weight is 57.1 grams per mole. So again, try the NIOSH Pocket Guide. I've got it pulled up here on my computer, and they give you all of this information really handily. So we're given concentration of methyl isocyanate as 0.02 ppm, and we want to know how much of this volume we need to collect to obtain at least 0.07 micrograms, so that our lab will give us a meaningful result. And so we need that much mass. So the first thing, let's get this out of ppm and into milligrams per cubic meter. So concentration ppm times our molecular weight, so we get into mass units, 57.1 grams per mole, and divide by volume. But what volume do we use? We use molar volume. So the problem tells us we're at 25 C and 1 atmosphere. So that we should already know, because we've calculated it numerous times on this homework set. That's going to be 24.45 liters per mole. So our moles cancel. We have grams per liter. And in this case, because of our units, we are already 1,000,000 times greater than we should be. So this puts us automatically, we're 1,000,000 times less than we should be, which puts us automatically into milligrams per cubic meter. So what is our concentration here? It was 0.02 ppm. So 0.02 times 57.1 divided by 24.45. That's 0.047. 0.047 milligrams per cubic meter. And that makes sense because we're going from 0.2 multiplying by roughly twice as much. So 0.047. And also the NIOSH Pocket Guide tells us that there's a conversion factor of 2.34 milligrams per cubic meter for every ppm. So 0.02 times 2.34 is also 0.047. So NIOSH Pocket Guide can be your friend in a lot of ways. In this case, I want to see you work it out. So now that we have this in mass units, we simply need to multiply it by some volume, a volume that we don't know yet, and that should give us 0.07 micrograms. So at this point, this is our new equation, and we're just going to solve out for volume. So our volume equals 0.07 micrograms divided by milligrams per cubic meter. So our units are not going to be right here, and we're going to have to adjust those. So 0.047 milligrams per cubic meter, if you make that micrograms, it's going to be 1,000 times larger. So 0.047 milligrams per cubic meter. And then down here, we could just do it right here. We could say 1,000 micrograms per milligram. Okay, so effectively that's 47 micrograms. And what does this come out to? 0.07 divided by 0.047 divided by another 1,000. So this equals 0.0015 cubic meters. Okay, so the problem asks for it in liters. So cubic meter is 1,000 liters. So 0.015 cubic meters times 1,000 liters per cubic meter equals 1.5 liters. So in order to ensure that you collect enough sample that the lab will give you a meaningful result, you need to collect at least 1.5 liters of this air if you're needing to be able to monitor down to 0.02 ppm.